Hey, Cassandra, how are we doing? We've got some Stats 101 questions to start. So if you have questions, put them in the chat. We're getting everything loaded up right here. We've got some questions. Where'd they go? Here we are. We're going to do the car questions to start. So we've got the 2 car questions. Oh, here we go. I'll just pull it right up. And let's check out the 2 car questions and how those are solved. If you have questions, put them in the chat. So we'll be working on different questions right here. And getting a new work pad up and getting the questions ready to go. Let's go timestamp this. Oh, we didn't mark the end of class. 1:19:45 end of class. Okay, 2-car problem number 1. First 2-car problem is going to be right here at 2:15. Let's go check it out. The 2-car problem version A. Okay, so these questions deal with 2 cars. Well, the first one deals with 1 car. I said that yesterday also. And so with this problem right here, we need to first draw out a table of probabilities. So always draw out what you have, give the information in a format that makes sense. So it gives you probabilities right here, and then we need to list out those probabilities as written. So let's go ahead and grab them. Okay, here we are. Go all the way down here. And there we go. Let's go ahead and take a look at the probabilities. So the first thing we have right here is 20% of cars will need to be repaired once. So when we draw out this table, we need to put the event of getting repaired once. And then we need the probability of said event. This would be a 20% probability. The probability a car gets repaired twice is a 10% probability. Got nice numbers this time. And 3 or more repairs is a 2% probability. I watched previous All-Stars, but I'm curious on how you giving the finding one with numeric. Oh yeah, talk about that here. You got it. Is there? Yeah, people want to talk about Project 1 here. We'll do that next right here. So we put Project 1. Project 1, we'll do that next. That's 1, Project 1. We'll do that after the 2-car problems. Thank you so much. You got it, Nathaniel and Cassandra. Yep, and I talked about it on Monday, and I also talked about the start of office hours. So start of office hours on Monday and class on Monday. So we'll talk about that here next. That'll be our next topic of conversation. Good comments. And so right here, let's give 100 points in the chat. So here's the probabilities, but what do you notice? We're missing the probability of your car gets what repairs. So like this question asks, we're missing the probability of the car getting how many repairs. Let's see. We'll take a moment, drink some coffee. Brian is powered by coffee. We're missing the probability of your car getting how many repairs. So we have the event, it gets 1 repair, 2 repairs, or 3 or more repairs. We have the associated probabilities of said event, probability being 20%, 10%, and 2%. We're missing the probability of what repairs, though? No repairs on your car. So the probability your car gets no repairs is going to be the complement of these right here. And we can find out the set of, or the sum of these probabilities, because your car could get either 1 or 2 or 3. And the probability of these would be 32%. We just added them to figure out the probability of some repairs. So the probability of no repairs is going to be the complement of some repairs, and it's going to be 68% right there. So either your car gets no repairs or it gets some repairs. These would have to be complements of each other, and we'll just kind of draw them that way in here to say that they are complements. Like either your car gets no repairs or it gets some repairs. And so the probability of no repairs would be this right here. The probability of some repairs is this right here. So we have a few of those answers already. And then no more than 1 repair, this one would be no more than 1 repair is the probability of these. Anyone in the chat real quick, what is the probability of no more than 1 repair? So it either gets 0 or 1 repair. Your car this year will either get 0 or 1 repair. It can't get both. It can't get 0 and also 1 repair, meaning that these are disjoint probabilities, meaning we can use our rules right here. What is the probability that your car gets no more than 1 repair? So your car gets no more than 1 repair. It gets either 0 repairs or 1 repair. So what would that probability be? We'll take a second right here. What would the probability be of 0 or, and that's a key word. We'll bring up the notes right here. 0 or 1 repair. So since I'm saying the word or, we want to use the addition rule right here, and I'll disappear off the screen, but we want to use the addition rule. And the addition rule says that when we want to add two events, we need to have them be mutually exclusive, which means if one occurs, the other can't occur. And we use the word or, and thus we add them. Now, once again, we talk about the example of you can get a dog or a cat, you cannot get both. If you could get both, there would be an overlap. They would have a joint to them, but they are currently disjoint because you can only get a dog or a cat. So in this example right here, your car either gets 0 repairs or it gets 1 repairs. It gets no more than 1, which is 0 or 1 repair, and thus the associated probability would be, we would just simply add them. We'll just put the answer over here. It'd be 0.88 because it's the sum of those two disjoint probabilities. So we have here, let's see here, 60 no repairs. I'm going to bring the answers up here on the side while I answer it. Probability the car gets no repairs was 68% from the problem. Probability no more than 1 repair is 88%, and the probability of some repairs is the complement of no repairs, and we should be fine on this. We've got it. Now, the next one is a trickier version of the problem, so let's put a break in the video. This one is a trickier version, then we're going to do project 1 right after this, so stay tuned for project 1. The next one right here is a trickier, more difficult version of this question, and here we go. Let's jump into it. So similar, I was curious, are we going over the activity? Yes, Robbie, yep, check out, there's a video, Robbie, for 320. That video is located, let me show Robbie where that's at real quick. That video you will see is on the channel. It's coming up right here. So to Robbie's question, the activity help multiple regression upcoming live stream, Robbie. So swing by this, join into this stream. You'll see your time right there in 3 hours. This shows my time here in Texas. It should be 4:30 Knoxville. Robbie, 100 points. Thank you for asking. Put you over number 1 on, oh yeah, you bet some 320. Let me take this, copy paste this. You bet. Abigail, you got that. Here, let me grab this Abigail right here. We'll do that right after the project, BS 320. Thank you right there. I'm going to re-timestamp this. So I'm going to get these things. You're welcome, Robbie, and you're welcome, Abigail. Great work. So assignment 7, Q1C. Okay, we got Abigail's, we've got Robbie's, we got everything good to go, and we've got the re-timestamping of this, so we can put it in the video for later. Let's go check it out. Okay, so we're back to the 2-car question, and with the 2-car question right here, we have 2 cars this time. This is the actual 2-car question. And you're asking, what is the probability that neither of your cars will need repairs, both of your cars will need repairs, at least one of your cars will need repair? So you have 2 cars. Best that we draw this out right here and we think about what we're seeing. So let's take the problem and let's open up a new Word document. And in the new Word document, let's draw out what we got going on right here. Here's your 2 cars. Fabulous cars. What kind of cars do you have? A Mazda, a Ferrari. I don't know. What kind of car is that? Here's your 2 beautiful cars. This is an SUV. Second car is an SUV. There we go. It's a little sports car and SUV. Now, you want to figure out the probability that neither car will need repairs. So this car did not need repairs, and this car did not need repairs. So the first thing you want to notice right here is we just said the word and. My first car did not need repairs, and my second car did not need repairs. The word and is when we multiply 2 probabilities. So let's go down here to the multiplication rule. We would need to confirm for this example, especially if it's a test question, that both of the probabilities are independent, which is kind of a big assumption for this problem, that one car will not influence the probability of another car needing repairs. Let's say, like, if my first car breaks down, that would not influence my second car to be more likely or less likely to break down. Bit of an assumption for this problem that the 2 probabilities are independent, that one car breaking down would not influence another car breaking down. Separate problem with separate math, but we can use the idea of independence to multiply and use the word and they have to be independent. Okay, so now that we know the rule we're using and the mathematics we're doing, we need to find some probabilities. Now, this problem right here gives you a lot of information. Right here, the event, and this is just what could occur, that your car gets 0 repairs, 1 repair, 2 repairs, 3+ repairs, and the probabilities associated with said event, like just what's the probability that could occur. And the first one we see right here is that the probability your car gets repaired once is going to be 9%. It just goes in order from here, and this is just where we're grabbing this to say 18%, excuse me, misspoke right there. It's 18%, hence highlighting helps. And now the probability of 2 repairs is 9%, just grabbed from the next part of the graphic right here. So right here, 9% repaired twice, and 2% 3+ repairs. So what we have is a similar situation to the last problem where we're missing the probability of 0. So this works off of the second rule of probability that the sum of all possible things has to add to 1. So let's find out how much probability we've added up here. We have 29% probability with these events. So then we can do 1 minus, which is the complement rule, to find out a 71% probability of 0 repairs. Now this is where we need to re-express this table to make the problem a lot easier. Instead of writing it this way, where we have the probability of an amount of repairs, let's just rewrite it the following way. We could rewrite our table such as we have the event of your car needs repairs no, and the event your car needs repairs yes. So we know the probability of these events from the table above. The probability of your car not needing repairs is simply going to be this right here. That is the probability your car would not need repairs. And the probability of your car needing repairs to some degree, because it could either need 1 or 2 or 3. So we're actually using the addition rule right here, or you could use the complement, because we can find it via this method right there, or the addition rule. So you'll notice we now have a new table telling us the probability of our car not needing repairs is 71% of the time for any car, and the probability of a car needing repairs is 29%, and it's going to help us solve this problem. Because when you look at this now, my first car did not need repairs and my second car did not need repairs could simply be rewritten with the numbers in here now of not needing repairs is 71% probability and not needing repairs is 71% probability. It's the probability of no and no. Once again, I am just putting in, since we're saying my first car did not need repairs and my second car did not need repairs, we're just putting in the associated probabilities and solving out the mathematics right here to find out 71% times 71 is 0.5041. So that should be the answer to the first problem right here. That's the probability right there. Do not round. Now the next question asks, both will need repairs. So we pretty much have this right here. It's sort of the same thing. We've got our 2 cars again. So this is problem 1. This is problem 2. And we've got our 2 cars right here. The first needed repairs and the second needed repairs. That's our big SUV right there. The first needed repairs and the second needed repairs. So now we're just going to substitute in those probabilities that we found. The first needed repairs and the second needed repairs. So 0.29 times 0.29 squared, is going to be the probability right there of both needing repairs. My first car needed repairs and my second car needed repairs. We actually did the problem earlier too. Got to find that worksheet now. I always try to explain these in slightly different ways right here. I'm always like, how can I don't know, try to improve it each time. Now, the last one is the tough one. The last one is the one where it's like, It says, what's the probability at least one of your car will need repairs? So if you think about this, there are many different ways this could occur. We've got here our cars. And in one scenario, we have no repairs, no repairs. In another scenario, we have no repairs for the first, and then the second car actually needed repairs, that scenario. This one, the first one needed repairs, and the second one did not. And this one needed repairs, and this one. Now, if you notice, this, we'll do a different color. This is scenario 1. And this is another probability table. These are the events now. And the probability of the events could be right here. Because one of these things must occur. It must be the case that either none of our cars would need repairs, one of our cars, could be the first, could be the second, would need repairs, or both our cars need repairs. So this is a probability table showing the case where neither of our cars need repairs. The event, first car did not need repairs, second car did not need repairs, and then we can find out the associated probability of the event, and we know it from above. The probability of the event is going to be 0.71 times 0.71, 0.5041. Now, what's interesting is the problem then asks, what's the probability at least one of your cars need repairs, which is this. We actually found part of it. This is part of this. That one is part of it, so that's not really going to help. But here's the thing. We just want to find one probability for all of this. And we know from every probability table we've been doing that if you sum up the probabilities, they have to add up to 1. So we don't need to find each individual probability for these. We do know one of them, but we don't have to find each one of those. We can go right here and say, well, this is the probability of the cars not needing repairs. So what's the probability at least one will need repairs? The sum of those probabilities has to be 0.04959, I think it was. Looks to be. Let's double check. There it is right there. And this is a good problem right here. Take a look at all the math on the screen. Try to write this down. Try to solve it. See if you can do it on your own. Draw the probability tables. It's really going to help to draw these things out. I always try to visualize what we're doing to hopefully help it make sense with the mathematics. And the more you write this down, the more you practice it, the better you'll get at understanding how to decode a problem and then turn it into the mathematics we need to solve it. And that's got all the answers. There's the previous version of it. Just trying to make it look nicer each time. And here we go. That should be it. Did we get it right? Yes, we got those hundreds. Awesome work. Let's go do some Project 1. Okay, it's time for some Project 1. More coffee. Okay. So for Project 1, let me get the notes we have open on it. Where are our notes? We have some really good notes on Project 1. Really good notes. Here it is. Okay. Executive summary. And here we go. We'll call it Project 1 example. Project 1. Okay. Let's go talk Project 1 example. 18. Here we go. Let's go check it. Only 18 minutes in. Wow. Okay, Project 1. Now, the biggest thing to know right here is the majority of your Project 1 executive summary is going to be what? The blue, the yellow, or the pink? Which of these colors represents the majority of where you're putting a lot of your work in? Now, they're each worth 2.2 points. 2.2 points. So they're equally weighted, so make sure you do them equally as well. But where I usually see mistakes? The pink, the blue, the yellow. Where's a lot of your writing going to be? Where I'm usually like, didn't do that part enough. Where is that? Where do you think? You know what we might do? We're going to do this. You know what we don't have? Let's go check this out. Here we go. World of Edcraft. Let's see. While you're thinking that over, the yellow, Cassandra, 100 points, you're right. So this right here is the World of Edcraft paper that we just got. It should be going out to Harvard Data Science Review. It's looking for stats to complete the project. Yep. So we're going to try to do an executive summary of the World of Edcraft paper that we just got put out here too. So look, here's an abstract. A lot of people say that the abstract is kind of like us. You've got some numbers in here. This is the abstract. So huge shout out to Dr. Andrew Lowe right here. One of Time's 2012 People of the Year. I always like, that's so crazy. He's such a really nice guy. Teaches at MIT. Just stellar individual. So Sloan, MIT Sloan School of Management. So huge shout outs to him right there. And Sean Willems too, who teaches at UT with me. But this is our abstract. This is kind of what you're trying to do right here. Look at the start of it. Online teaching at higher education institutes has become a much higher priority in the face of the COVID-19 pandemic, but most faculty, blah, 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 all this stuff. And then you get down here into kind of what's going on, what we're doing, what's the point of it, and what we have. This is a little bit different. It's an abstract to a scientific paper. But if you were to think about this and take this paper right here, it'd be really hard to turn this into an executive summary. But what would we need to do? If you go down here to, there's so many cool things if you look through this. There's my home setup right there. So this is what I'm teaching from currently. Like literally right now, that microphone you see is the one I'm using. If you go down to this and you were reading through this report, you would want to take something right here. And let's go here and take a number. Talking about the classes right here, and this is where the tables should be at, because we just put out the new tables. Where's my tables? There's people who've also been doing what we're doing. Trying to see if there's a good example. Here we go. Where's our numbers? I know we quoted a lot of numbers in this report. Here we go. So here are the evaluations of the classes based on and student performance. The class averages with the YouTube classes versus the summer. So you see, actually, the first time I taught YouTube, grades were a little bit lower. But lately with YouTube, the grades have been towards the highest was the hybrid. So you see all the different teaching modalities right here I've done with grades in the class, the standard error, the estimates to help us communicate that we do have students liking the class, students getting good grades. So we might say something in our executive summary like, let's go right here. If we're doing the numeric backing section, Brian found that the YouTube format of class had, we don't want to go full paint on that yet, had an average of 84.5 for the fall 2021 section. Comparatively, this was on par. And I'm just going to randomly say the numbers. I can't remember them. With the in-class sections he taught in spring 2020, which had an average of 84.1. What am I doing in my executive summary right here of Brian's report? Now, it's a major long report, but what am I doing in this yellow portion right here? What am I doing? What do you notice I am doing, which is very important, and how I'm communicating the results in the report? And this is just me writing an executive summary for a report you just saw right there. If I were to write an executive summary for a business report, it's different than a scientific abstract to a paper. They have different goals, similar-esque. But what do you notice I am doing with my part of the executive summary? There would need to be more to this. But what is the important thing I'm doing? And look at the yellow portions, because that's just like what we're doing. And then this is like an example of it. So I'm giving that numeric backing. Reggie, great answer, 100 point right there. The plot the question. Yeah, we can do some 475. You got it, Shiv. Definitely. Let me put that on the agenda right here. We got more than enough time today. So let me put that on. We've got one more thing after this. BAS 475, assignment 5, Q1A. Good question, Shiv, right there. So we're giving the numeric backing right here of what we're talking about in the project. So once again, I'm going through the project right here, finding values like you see right here, and then giving them as numeric backing. So we would do that. Now, what we need is we need an opening, and we could say, doctor. We'll say we need to color this in yellow, blue. Really? We could say Dr. Andrew Lowe, Brian Stevens, and Dr. Sean Willems. Gonna get his name spelled wrong. I want to make sure I spell his name correctly. Willems. Good. Dr. Sean Willems were tasked with investigating new online teaching strategies at the University of Tennessee, or we should say at MIT and the University of Tennessee. Both or all three used OBS and advanced technologies to improve their teaching online. So this right here is kind of our, or we could say who the report is for. This report is drafted. We should probably put that at the start. This report is drafted. Everyone's going to write this now. For the administration of MIT and UTK. So you don't have to say this report is drafted. I mean, you might say this report is for so-and-so, but like making it clear, who is this report for? What are we researching? This report is drafted for the administration of MIT and UTK. Dr. Andrew Lowe, Brian Stevens, Dr. Sean Willems were tasked with investigating new online teaching strategies at MIT and the University of Tennessee. All three used OBS and advanced technology to improve their teaching online. Brian found that blah, 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 blah. And then we might go into Dr. Lowe. We don't want this anymore. Dr. Lowe found with his students class engagement increased 54% comparatively to, and this is a made up number, I'm just kind of, rather than going through the whole report, comparatively to his non-technology enhanced education online. Does everyone understand right here that in the kind of results of the executive summary, we're giving numeric backing? These are like the key findings. Like this right here is the key findings. So if, let's say this is the report right here, what would you suggest? Like, what are we going to suggest to the administration of the university right now? So think about this right here. Like, we're going through, we've said who the report is drafted for. We're giving the key findings. We're giving the numeric backings. Please note that I am giving numeric backing to, it increases performance. Well, how much? 54% increase. That's a made up number. I just want to point that out. But I'm giving the numeric backing. The last thing we need to do is give a what? What do we need to do lastly right here in our report? The last thing we need to do in our executive summary of this report is do what? For the executives, which is what they're probably going to read. They're going to read this and be like, okay, this is the report drafted for us. It's blah, 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 blah from these people. This is what they're looking into. Here's what they found. So then what would we do right here? So we're taking the whole report, condensing it down, and then the last thing we do is we give what? So what would we do right here? I have to reach off screen to get to that. The last thing we're going to do is we're going to give an action item, which is like, what are we going to do? That is like, do this. We can be very direct in it. So let me decrease font right here. There you go. The last thing we're going to do is give that action item and kind of talk about what we're going to do. So let's go ahead and do that shading. Not future research yet. Good answer, Reggie, right there. Future research will be its own thing in a moment. We need to give an action item. And the action item would be something like, from the results, I feel like everyone's going to write that now. A lot of similarities I see in reports. I got to watch because I look for plagiarism. And then a lot of, I would do 5. It's not like you're required to do 5. I would kind of try to find 5 key findings. That's just usually my way of making sure students have enough because you don't want to go light on it. You don't want to say Monday had 12%, Tuesday had 8%, Wednesday had 6%. Then it's like, well, what do you mean by that? Like, you should, try to give key findings, like big things that are important, like Dr. Lowe with his students, class engagement with his class engagement. Dr. Lowe found with his class engaged that Dr. Lowe found that his class engagement increased 50% comparatively. Once again, this is just me making up stuff. Technology enhanced. From this results, we have 2 key suggestions. And continue. First, both UTK and MIT should expand their funding for online teaching by 20% for the next semester. The last suggestion also, a panel of individuals should be created to research new ideas that could be introduced into online teaching. So we're suggesting the creation of a panel to kind of further the ideas of online teaching, and we're suggesting that funding increase. So we need a panel and we need some funding, and those are my action items from this. Now, when you get to the future research, it's things that go beyond the project right here. Ideas that go beyond the report are very important, and this is future research. So in the future research, you would say things like, the panel created due to the action item will need research around the finding, or will need to conduct research. We'll need to conduct research. We suggest they collect data related to. It's too connected there. It's fine. It's going beyond. This is like new ideas, things we haven't done yet, and it's kind of like it's not quite an action item. Let me change the wording of this a little bit. Let's say in the future, we need to collect more data on student satisfaction with courses. I can't spell anything. Satisfaction with courses. Variables related to this would include engagement, performance, and ratings via TN Voice. Right now, there is limited questions on TN Voice related to blah, 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 blah. And so now we're getting to things way outside this report, dealing with like changing TN Voice, all these things we haven't done. It's not quite an action item, but it's things that we're just brainstorming on. And this is just more brainstorming, like not quite action items like we're going to change TN Voice because of this. But in the future, we really need to be collecting more data on this. It's not quite an action item. It's a little more open-ended. Like it's like a discussion at the end, like, well, we could do this. The action item is very direct. We have two key suggestions. Like we need to increase our funding and we need to create this panel. These are like direct, like we are doing this, we are doing this. That's what an action item is. Here's who the report is for. Here's what we found. Here's what we should do. The future research is more of brainstorming. Is this making sense to everybody? Let me know if you have questions on this. But the future research is more fluid, like, well, we could start looking into this. We could start doing this. Here's some ideas. I'm just kind of putting them on the table. Where the action items are more direct, where you're like, hey, look, we really need to be doing this. Like, we should do this, increase funding, and we should also be doing this right here. So if you look at how these are kind of sectioned off with the color coding, you can see you would probably need to expand this right here, at least for this report. But you can see the different parts you'll be graded on, 2 points, 2 points, 2 points. And then down here for the future research, you're moreover just doing a brainstorming session, kind of going beyond the report, going into new ideas, things like that. Any last questions on this? But try not to be short with your words. Putting on a little extra few sentences never hurts, unless you're going like to a page, 2-page. If you feel like you're going too long, email me. I've already given a lot of people a lot of suggestions, but you're mainly just summarizing a full report into an executive summary with, once again, who is the report for, what were the key findings with numeric backing, and then what is the action items. And then lastly, you're doing a future research at the end. Hey, Brandon, good to see you here. If you have questions, let me know. We just talked over the project, kind of went over the structure of what you're turning in, and that's got it. Let's head back here to the main screen. Could you go over we're going to do a full activity video later, Drew. Does that work for you? Will you be able to swing by at 4:30 Knoxville time? I could do it, especially if we don't have many questions. So if we run out of questions, I will do that. But we do have a video. We're going to go the whole activity at 4:30. And especially if that time doesn't work for you. Here's the link in the chat. And it's perfect. Awesome. So we're going to put it all in one video right there, but we can do it. If it gets slow, we could do it. Definitely. So the project, other reports, the different charts. Yes. Going over like the different things throughout the report. Does that make sense, Cassandra? The different charts in there are the different things that you'll be going over, giving the results. You got me Tyler and website. Brandon, did you email me about or did you message me about the database, the payroll database thing? Was that you, Brandon? I'm trying to remember. I think so. Was it? Because you need to do the view source on that, and then need to web scrape their database probably. I think Brandon might be, because that's the last person I talked about web scraping. Yeah, that was you. Nice. Yeah, it'd be super interesting. Get it. Go. get it. It's always interesting to me. Like I like that UT posts everything. It's interesting because I've had students be like, I looked you up, and I'm like, okay, cool. It's very funny to me that people but yeah, UT posts all the salaries, public institution. It's always funny to me. Yeah. Let's go to the next question right here. I'm all about that. It's like, yeah, let's let information be out there. We're grabbing the assignment right here. Assignment number 7, multiple regression for 320. So 320, got some 320 stuff coming up here. I cannot speak. Whew, losing my words. Let's do some 320. Okay. And 320 is at 36.55. Let's do this. Here we go. Okay, so the first question we have right here is 1C. What does 1C ask? Fit 4 simple linear regressions. Complete the following table. Report the coefficients to the nearest integer and the p-values. Keep 3 digits after the decimal. If a p-value is less than 0.001, record it as 0, along with whether or not it is statistically significant. Might be some nicer ways to do this. So you have the first one right here. The coefficient of average temperature is already given. The p-value right here is given, and the significance. So this is 4 simple regression models. Does that make sense? I'm trying to remember who was asking this, but this is sure. Oops, what did I do? This is 4 simple regression models. 4 simple regression models, and there's actually a really neat way to do this. We're trying to predict demand. Make sure I do the right problem right here. We're trying to predict demand. Good job, Abigail. Great work. So we're trying to predict demand from these variables. So let's take a look at the data set. This is the EX4 data set, I believe. There's the loading of the data, and let's go right here. Do we have EX4 already in the environment? I think, what did it load in? Let me do something crazy. I'm going to reload that. Had a bunch of stuff loaded in. Whoops, wrong button. Correct. No check regressions on this. Check regression checks conditions. There's the bike data right here. So we're looking at the bike data right there. We're not using the EX. Got to use the bike data. And you see right here, we got stocks and we got bikes. So we got stocks and we got bikes. So with the bikes data right here, let's go right here and check it out. You ready? So we're going to go right here. I'm not going to do eval false. So I've said eval supposed to touch it. Yeah, it's fine. Okay. So the bike data is this data right here. Sorry, STR. STR is the structure of it. Watch out with how much output you get. How many variables are there in this data set? Abigail, how many variables are there in this data set? You're viewing the same thing. If I were to go up here and click the following, how many variables are there in this data set? So real quick question on this. How many variables are there in this data set? We want to explain the demand for these bikes. How many variables are there in this data set? We want to explain the demand for these bikes. How many variables are there? There's 5. Well, 100 points right there. There's 5 variables. We collected data on the demand for the bike. 4x is good answer. Good follow-up answer. There's 4 x's. Either way, if you had said 4, I would have said there's 4 x's. If you said 5, I'd say there's 5 variables. So the y variable of interest is demand, and the x variables are what was the temperature, what was the effective average temperature, what was the humidity, what was the average wind speed. So those are the different variables throughout the model right there, and we can go in here and start to look at these. Now, a really quick and easy way to make simple linear regressions is to do something a little bit odd right here. We can make a simple linear regression by doing the following. Linear model, y tilde x, AVG temp, it is that way, data equals bike. And then we can get the coefficients of this with the following, and let's confirm. The coefficient, it's up here. The coefficient of bike is this. Does that make sense what the coefficient of bike is? The coefficient of bike is 139 because rounded. And then right here, the p-value, how to find the coefficients. This right here is the coefficient. This is the p-value, which is basically 0. That is, if you're wondering, I think, okay, are you seeing it, Abigail, now? That p-value is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. That's that p-value right there. It's a very small, basically 0 p-value, which means it is statistically significant. So what I could do, and this is probably one of the easiest ways to do it, is to take right here and change this to effective average temperature and rerun the model. So now I can rerun the model, and if you just want to put it in the chat, Abigail, what would be the coefficient? Ah, nice job, Abigail. So that's good to see right there. That answers the question. And then you can get the coefficient of effective average temperature right here, which if you want to put that in the chat to confirm, you can round it to whatever it is rounded. But the coefficient of effective average temperature should be viewable, and the p-value for the coefficient should be there. And also the statistical significance should be there. That hopefully seeing this is like, that's what we got. And then just changing, yep, 128. And then you can change it. Now, what's really interesting, watch this, Abigail. If I do the following, I can actually find the first model, the second model, each model. I should stop unless we see all the answers. Because I'm just taking the Y column, because this is the column space. Here's the row space. And I'm just taking the Y column, column 1, and column 4 right now. So this is average humidity, because average humidity is column 4. So I'm actually saying take all the variables, but I'm limiting the variable selection to the first and the fourth. So you can actually write every model pretty quickly if you go through here and you permutate the variables like this. And then you'll literally have the first and second, first and third, first and fourth, first and fifth. And I'm using the code right here to grab every variable, but then I'm limiting it on the data set. Should we do it like that, or can I just copy paste the chain? Either which way. Either which way is fine. Yeah, this is just an easier which way to just change a number, but you could just also go through here, and it's not too hard to go through here and then copy paste change the X. Like this is, and it might make more sense to people to do it this way. But if you notice, the copy paste is your best friend. Like you can write each of these models like this. I probably wouldn't call all of these M. I'd probably call it things like this, or I'd call it like M AVG temp. Like if I'm going to store these for future use, I would call it things like this. Does that make sense right here, Abigail? Like I would probably name my models different than MMMMM because you're overwriting the same model. I would store them as different objects, probably keep them of similar length, like m.average temperature for the model made from it. Yep. Abigail, I'm gonna throw you 500 points. Thank you for asking about all this. This really gets into like how to write good code and one, understanding what you're looking for, the coefficient of these models. Like this is the coefficient for the average humidity model, which would go right there. There's the p-value, so I wouldn't round this one. I would just literally just put that right there. Make the table look pretty again. So I would do that. This turns into a table when you knit it, I think. Let me look at what it looks. You can look at what the document looks like knitted if you click that button, and it will turn into a table. So I think it's smart enough to make it look like a table. And you can actually edit the values here if you want. Don't put that in there. Whatever you do, don't do that. Someone's gonna write that. I'm like, no, it's not the value. It's not the value of average humidity. It's the value right there. But all this right here, so you can actually see what your document looks like knitted if you do this. And yeah, so don't put in that value right there. Any other questions, Abigail? What are you thinking? I'm glad this helped out right here and kind of talking through how to make. You're making 4 simple models right here, 4 simple regression models. Any other questions? What are you thinking about? Let me know a little more on 320 right here. Ask any question you got, or if you could, just be like, we're good. I think you've already said, okay, perfect. So I'll assume you're good. We're going to do a little 475 right here in a second. 475. Let's go check out some 475. Going back to the main screen. So we're about to see some really cool stuff right here, especially if you're in 320. 475 is really good practice coding. We always try to expand our knowledge. Our goal with all of our classes is that each class kind of grows your knowledge so that as you go from 320 to 474 to 475 to 479, 471, you're building a skill set. It's not that you learn something and never use it again. Our goal is, awesome, Abigail, keep working away 100 points and keep asking questions whenever you got them. If you run into something you're like, hey, wait a minute, I don't know how to do this, then we'll help out. So this is 475, question 1A. Let's go check it out here. Okay. So with this question, we are talking about, I think, how to visualize the data. Oh, we've done this one a little bit right here. So this is Q&A. Plot the data to find the regression model for demand with temperature as an explanatory variable. Why is there a positive relationship? Now, I'm going to skip over this part and let's do a little bit of visualization right here. Brian's working similar, but kind of the same model. You know what I'm actually going to do? I'm going to make a model from... let's incorporate 320. We got the bike data for 320 already open. 320. Okay. Let's try this. You ready? We're going to try to turn 320 into a TISBL. Chapter 12 quiz. Of course, Malia. Which question do you have on it? Let me know. We'll do some more 201 Chapter 12 quiz. Tell me which one to do. We'll work on it. We'll get it done. We're going to do a little 475 here, and then whichever question you want to do, we can work on it. So this is using 320 in 475. We're going to use that same bike data we just had. We have 389 observations. We're going to pretend here for a moment that the data starts in like 2015 and goes on by a week. Let's say this is weekly data. You can send me the code, Chip? So we'll take a look at it here in a second because we're going to plot this. We're going to make a linear model. So we're going to do like a similar example, and I might answer your code on Discord. I want to do like, I've done a lot of, I think I might have done this one, also, I don't know if I've done this one during office hours, trying to do like different but similar work to show new examples, because we always want to incorporate our ideas into like, could we do this for a different data set? So if we have the bike data set is not a TISBL yet. A TISBL is a time object tibble. A tibble is a table in the tidyverse. Lots of new things right there. So what we want to do right now is we want to create, let's say, date. Date is going to be a sequence, and we'll say from equals 2015. It's probably going to get mad at me right here. Let's say 2 equals sequence of dates I'm not the best of. And I'll say length equals 389, and let's say by equals 1 week. It's probably gonna get mad. Let me check out. Make a sequence of dates. Sequence of dates in R. SEQ. Did I write SEQ? Did I SEQ? Here it is right here. Should put it in that. Sequence, year, month, day, by years. Okay. So length. It should be weeks, I guess, then. Okay. So, or 7 days. So length equals 389 and by equals 7 days. There we go. So now this is weekly data right there. So I have created a week variable. So we would say we're pretending this starts on 2010 and it's weekly data right here. So we're going to store this as the date, and that'll be stored as date. We're then going to take the date and we're going to plug it into the bike data set as date on the bike data set. Is this making sense, Shiv, what I'm doing right here? Because then what I'm going to do is I'm going to go as.tisbl, and we probably need to mutate this because it's going to be weekly data. Well, it's not daily data. Weekly data. I always get into a little trouble on my tisbls. Look up my FPP3 handbook for this. The FPP3 handbook is really great for making sure we bring in things right. And so if we have weekly data, here's weekly. Here it is. It's year week. Boom. So we need to go ahead and take this, and he shows how to do it with the mutate. We're going to take and mutate this. Where's our mutate? There it is right here. So let's take, we need to mutate and then bring it in as a tisbl. So we're going to take the data right here, and we're going to go bike. There's the bike data set. We're going to bring it through the mutate. We have right here date, and this is the date. There it is right there, and we should, nice and neat. It's mad because month is not found. Index equals date. And it's mad again. A valid tisbl must have a distinct rows identifier by key. What is it mad about? Date. Let's see right here, the mutate on this. Okay, it's fine on that. Index equals date. Let's say bike Tibble. Look at the bike Tibble object. There's the date. And what is it? Oh, look at this, look at this, look at this. That's the problem. It's mad because this is the same. Okay, looking at the object helps with it. Year, month. No, it's not year. So it shouldn't be. Oh. We just said this. There we go. So is this making sense, Shiv, what I've done right here? I'm going through the FPP3 methods with a different data set, and then we're going to do very, very, very similar code to this. So we're taking the bike data from 320, treating it like a time object. Leo, good to see you here. And Malia, let me know if you have any questions on the chapter 12. We're going to go back to some 201 probably after this. But now we've turned this bike data set into a bike Tisble object. Bike, and let's say Tisble. So there's the bike Tisble object. Now that we have a bike Tisble object, and so this requires that you've done the first part of the problem right here, we're going to go and we're going to make the time series model from this. So to make the time series model from this, we need to go inside of here, pipe it into the next argument, and go model, time series linear model, and inside of this, we are going to put the demand, which we want to explain via the AVG temp. And it should like it. It does like it. There we go. And we're going to call this, let's say, linear model. Now, 320 might see this is just your y tilde x. The data is being piped through. Shiv, how are we looking on this? This is how we would make the time series linear model for this. Shiv, does this look accurate to you? Is this making sense? Like, okay, I've taken my data that I have from the first part of the assignment, and then I'm piping it through to the time series linear model right here to make a model predicting demand from average temperature. So now that we have this model, this is what's really great about it. It wants us to plot this, right? Plot the data and find the regression model for demand with the temperature as an explanatory variable, which we're basically doing right here. It's literally almost the same because this is a very similar data set, hence why I wanted to use it right here. Why is there a positive relationship? So once we make this a little bit different, I might even try some stuff right here. We'll call this fit. So here's our model fit, and we can go here to report. And if you look at the report, what does this look like? And actually, I think if you remember when we were doing 320 just a second ago, I did, Leo, and it seems to kind of work. We had buffers yesterday. I changed it to 30 frames per second. Do you see a difference, Leo? Tell me if you see a difference. We did have buffers yesterday. I changed to 30 frames per second, though. So we're 1080, 30 frames per second with a 3000 bit rate up, I think now, which we still had buffers yesterday. We haven't had a buffer today. I'm jinxing it though. It's gonna happen. It's gonna happen. But here, if you look, we were just doing the work in 320 and we literally are getting, awesome. I hope it could be a wire I have, Leo. Like I start to wonder, is it a wire? Is it the router? Is it the modem? You know, so it's intermittent, which is not good. But I did change it. So right here, why would we know there's a positive relationship? So this, Abigail, you might see this. Why would you know there's a positive relationship right here between the two? Why would you know that there's a positive relationship between the two? How would we know that there's a positive relationship between the two? Does anyone know? How could we determine? I'm going to go grab a little more code right here. How could we determine that there is a positive relationship between the two variables? How would we be like, oh, there's a positive relationship? How would we know that? And I guess this works. I'm not the biggest fan of this. I guess he's doing that. There's the fit. So I guess we could run that through it. We could run this. We know that there's a positive relationship because right here, the coefficient is positive. That indicates a positive relationship. I'm grabbing this code from the book right here. Just stop by real fast. What is Xeria too long? Mine is way over. Oh, yeah. 4 to 6 is it's got to be like really 4 to 6 strong sentences. Emma, if you want to send it to me, I could take a look. Probably you're all right. If you want to send it to me, I could take a look to tell you if it has the components. A lot of people, like if you do 4 to 6 really strong sentences, you can do it, but 4 to 6 is going to be probably too short for most people. Probably. And here is our y variable. Oh, then we need to do fitted, and then the x variable is this. Let's see if it runs. Oh no, average temp not found from the fit. Time series linear model. If you have gigabit speeds, make sure you have at least, oh, Cat 6. Ooh. I might order some this weekend, Leo. Thank you, Leo. Remind me in a moment, we might literally go over here and order some. Where is the fit they've stored right here? We should have this. So consumption income. Consumption is the Y. There's the Y. Consumption's the Y. Oh, they're putting it as the X. Okay, that's why. There's that. That's weird. Yeah, the fitted. Okay. Whoop. The fitted mod. Why is it? Oh, because I didn't do the points. Haha. Haha. So now here is our fitted model. And what's crazy about this? Oh, it looks pretty good. And then the labs, fitted model, the data. That's right. Percent change. No, let's put it right here. Bike demand. Right there. Cool. And there's the model. Color equals red. And line width equals 3. What did I just do? Ah, it's too crazy. There's the model right there, and we should be good. And let me see if this looks better, because I've talked to Petrie about changing stuff. So let's put this through right here into a visual. And then let's put the visual. We'll do it the easy way. ggplotly of the visual. See if it looks nice and neat right here. So this is a great job, Emma, right there. Yeah, send it my way. This is the visualization of what we have going on right here. And I don't want to compare this to what we have in 320 because I was trying to make the best time series regression we could make. And I do want to add one more thing right here. Plus easy, GG easy center title. So, oh, we'll just do it this way. Easy center title. Does it work? There we go. Bike demand. So there we go. Bike demand right there from 2010 to 2015. And here's our visualization. So this is the visualization we are getting, Shiv. So how does this look? Is this making sense? This is the visualization of the data versus the actual. There's a little bit of a nonlinear relationship right here, as we can see. And then we could use the 320 methods on this. So compare this to 475 to 320, where we go here and do demand tilde. What was the Y variable? The Y variable is... I lost my Y variable. Where is it? Right here. Y tilde X comma data equals. And we are using the bike data set. And there it is. And if we make the model and we visualize the model, so much easier, right? And there's the visualization. So comparatively, the two, here's the visualization right here, and here's the visualization here. It's actually, and I promise you this, it's actually the same data being visualized. You can see it a little bit better if I make it this way, kind of scrunched in the picture. This is going to be right here. Well, it's kind of doing the demand on the bottom, which are the actual values right here of the demand versus the fitted model right here, the fitted values, and the line itself fitted. So pretty decent, good way of doing it right here. And we could actually look at different ways of visualizing it and understanding what's going on with our data. So there is a positive relationship right here where we see higher data values, higher fitted predicted values, and we have the actual values versus what we get, predicted values. So yeah, good stuff, good stuff. But that's got it for there. And so Shiv, let me know if you have questions with what's going on. Good stuff right there. I'll take a look at Discord here in a little bit. But we'll review. I don't want to put all the answers out there. So I'm like, I want people to kind of work through there and look at the model and see what they're kind of getting for predictions. The next question we had was at chapter 12. Let's over to the main screen. What questions do people have on chapter 12? We got some Stat 201, chapter 12. Let me know. What questions do people want to do on chapter 12? Let me look for Cat 6 cables really quick right here. Is there Cat 7 Ethernet cables? Oh. So why not Cat 7, Shiv? Or not Shiv, Leo. Would Cat 7 be better? Is there Cat 8? Because that's like the, there's Cat 8. Chapter 12, question 2, quiz. What does it say, Leo? Because those change. Those are different each for every person. There is, but probably don't have a 450. Oh, wait. Is that what they're rated at? 450 gigabits per second. It's not worth it. So wouldn't it? It's just like too much. Like it's just not worth it. They don't seem to be that expensive. I might try changing my Ethernet cords and stuff, like just replugging, like pulling. I might order a bunch of new Ethernet cords that come in this weekend. Just replug up all my Ethernet cords, and that might help speeds because you're just a lot of times it's hardware limitations. Good point right there, Leo. Trying to figure out the hardware. There's Cat 9. No, I only see Cat 8. People Google Cat 9, but so what I need is like I don't need long wires. In order to like. I want like gold plated. Don't need long wires. Let me. There's length. Should have length of Ethernet cable. Here we go. No, I don't want 1 foot. Yeah, I need to look at this later. Like the tiniest. 10 pack of Cat 8 cables. 40 gigabits per second. Wow, that's crazy. A 10 pack. Oh, let's try this. What people saying? 93 ratings. Let me go to highest review. 2 seconds. I'm going to order these right here as we're talking. Then we'll do chapter 12. Highest review. I'm always afraid when it doesn't have many reviews. Cables direct. Monoprice. I like Monoprice. I know Monoprice. A 0.5 foot. Wow. And it's like smallest wire you can get. A lot of 0.5 feet wires. It doesn't have a ton of reviews. I'm always scared. Like that. Sponsored. 2% bad reviews. 0.5 feet. Can't use 0.5 feet. Okay. Let me order this pack of cables right here. How much? Wait, this has a ton of... It's Cat 6. I'm going to go with the crazy Cat 8. 2 seconds. Where did that go? I just saw it. Exciting times. Let me go back because I had it up. Oh my gosh. I had what I was going to buy. Oh, those are all 0.5 cable length? Oh. No, yeah, I need to figure this out later. Yeah, message me all the gold plating and marketing BS. Oh no, I fell for the marketing BS. Winning symbols under the soda caps. Let's do that. Winning symbols under the soda caps. Winning sodas. Okay, I'm gonna get that pulled up right here. Leo, if you have a suggestion, I'll probably buy it. You're probably right. All that gold plated stuff is marketing BS. But gold plated, it transfers faster. It's the connection. The gold plated. Send me your suggestions, Leo, and we'll take a look. And I'll rewire all my stuff. It should be in by Friday, hopefully. 5 pack of light bulbs. We're going to find the soda question. Yep, on the soda question. Hey, soda question. Send me those links, Leo, and we will do that. We'll order those wires. Okay, here we are with the soda question. Let's do it. So a manufacturer, exactly. That's why all my HDMI were gold plated. So the manufacturer is going to put winning labels under 17%. Thank you so much, Leo. 17% of soda bottles. You are buying a 6-pack. What is the probability you win something? What is the probability you win something? So we want to see the probability of winning something. Go away, next question. Probability of winning something. And with this, what is going on with this question? Well, here we are. Let's take a look at the question. 2 seconds. In this question, it looks the following way. You're going to buy a 6-pack of sodas. So we'll draw some Coca-Colas right here. Thanks, shouts to Coca-Cola. What would you love, Leo, if you... So what is that probability of? You're close-ish. But Leo, what would you love to have happen if you bought some sodas? What would you love to have happen if you bought some sodas? Just we'll talk through it here for a moment. You'd love it if all your sodas were what's? You buy the sodas and you're like, whoa, oh my gosh. What would you love for all your sodas? What would you love for every single one of them? Would you love to see this? We're just going to talk through some probabilities here for a moment. What would you love for every single soda as you open them? As you open every single soda, you'd really like for each one to be what? And don't worry about the question yet, because we'll get to it. I got all of them exactly, Leo, 100 points. You'd love it if every soda was a winner, right? And that's what we have illustrated right here in this drawing. You'd love that. Well, the probability of winning is 17%. Well, they're not all going to be winners, probably. Probabilistically. You're probably going to have some losers. And the probability of losing, as Leo has put in the chat right there, is 0.83. Now, Leo, just illustratively, what have I drawn for you in this illustration right here? I've drawn an example where you buy a 6-pack of soda, which this would be really cool. But I've drawn an illustration where your 6-pack of soda, you have what? I'm going to do a little better handwriting right here. I've drawn an illustration where you buy a 6-pack of soda and what? Which would be super amazing. You might be like, but there's this many of them. There's 4 winners, 2 losers. That's just an illustration of that. And so it says up here, what's the probability you win something? Tell me yes or no. Did you just win something? Did you win something? Did you win something in this instance? Did you win something? So we just want to look at this and be like, did I win something in this 6-pack of soda? Did I win something? Did you win something? Yes, you won something. Yeah, you won 4 times. You won something. How about if I do an illustration right here? It's going to let me grab all of it. I'll do it this way. How about... So close. How about if I do an illustration this way, Leo? Where I draw it... I draw it this way. Did you win something in this second illustration here? Did you win something in illustration number 2? In illustration number 2, did you win something? So just look at illustration number 2. Be like, did I win something in illustration number 2? You bought your 6-pack of soda, you opened the caps, and then did you win? Yes, but you won 1 time. Here's the thing. There's only one scenario where you don't win something. What is the only scenario where you don't win something? Let's talk about a scenario here where you don't win something. What is a scenario with your sodas where you don't win something? What is the scenario with your sodas where you don't win something? What is the scenario where you don't win something? What is the scenario where you don't win something with your sodas? You're like, oh, I didn't win anything. What is the scenario? Well, you lose all the time, right? So could I state this, if the problem would let me do it? Could I say, either you win something or you don't win anything? Is this a true statement that either when you buy these sodas, you will win something or you won't win anything? So either you win something or you don't win anything. So you will either win something or you won't win anything. Is that true? Like, you're either going to win something when you buy those sodas or you're not going to win anything at all. Does that make sense? You either win something or you don't win anything at all. Well, take a look. You don't win anything at all is scenario number 3. And one thing we would know about this is if I've said something that is either this is true or this is true, what is the probability of this right here, Leo? Mathematically, what is the probability of you win something or you don't win anything at all, because it's one of those things must occur, and it's like you either win or you don't win something. You will either win something or not win something. So we could say you do win something or you do not win something, making it a compliment or really good language to say, like, you either win something, you do win something, or you do not win something. Pure compliments right there. You either will win something or you will not win something. The probability of these added up, because the or means we can add them. So here we'll write this as another thing down here. The probability could be that we're adding these and they have to add up to, well, you're on the right track. So what is the probability going to be right here? Because then we're going to solve this. So what is the probability going to be if we add these up? What is the probability going to be if we add these up? We say either you win something or you do not win something. If we add those up, the probability of those would have to add up to what? They'd have to add up to what? So you either win something or you do not win something. One of those things must occur. And that's the hint right there. They must occur. It's either the case. Should equal 100%, right? Good stuff right there. Now, here's the thing, Leo. You're on the right track because I think you're figuring it out. You are talking about not winning one time with 83%. It is, yeah, Brandon, this is a tough one. And this is where, like, we draw it and we say, okay, you win something or you don't win something. So tell me this. What is the probability your first... Let me just tell you, your first soda, what's the probability it's not a winner, Leo? The first probability you open up, what's the probability it's not a winner? Just the first one. Only the first soda you open up. What is the probability that first soda you open up is not a winner? The very first soda you open up, what's the probability it's not a winner? What's the probability that very first soda you open up is not a winner? So that's just go by straight the problem right here. The very first soda you open up, the probability it's not a winner is 83%. Exactly, Leo, exactly. And then the second one has an 83% probability, and then the third one, and then the fourth, and the fifth, and the sixth all have 83% probabilities, and each soda would said to be what of the previous soda you open. Each soda would be what of the previous probability of being the other one being a loser. Each soda's probability of losing is what of the previous soda. Independent. Rock knows. It doesn't matter if you win or lose on the previous soda. The next soda is just a random soda you're opening. So what can we do to these probabilities? We can multiply them. So because they're each independent, we could say right here, the probability right here is going to be of not winning something is simply going to be 0.83 times, and we could keep multiplying out right here, 2, 3, 4, 5, and we get the following. Now, this is where we're super close to solving it now, because we want to figure out the probability of winning something. So let's say we take this mathematical probability right here. Well, that would be the problem you win on every... Oh, I didn't do 6-pack. I did a 5-pack. That's the light bulb question. 6-pack. There we go. 6-pack. So first one you lose, second one you lose, third one you lose, fourth one you lose, fifth one you lose, and sixth one you lose. So this right here is the probability you lose on all 6. You do not win anything. Does that make sense? This is the probability of not winning anything. So this right here is the probability of not winning anything. Let me color code the separate things. We want to figure out the probability you do win something. So to figure out the probability you do win something, we're so close to figuring it out right here. We want to figure out the probability you do win something. And so what should we do right here? What should we do to figure out the probability you do win something? That's the thing we're interested in. We're interested in that yellow thing right there. So let's solve this mathematically right here. And 2, 3, 4, 5, 6, that's what it solves to mathematically. And if you take a look at what we have on the screen right now, it should be clear what we can do to solve this. Leo, what do you think we could do mathematically to solve this? Because we want to find out that yellow probability. So we found out this right here. We know an equation, right? So don't worry about all the decimals. I think it wants it only carried to 3 decimals. So we should be good with that. What can we do here mathematically, Leo, to solve out this equation to figure out the probability you do win something? Because either you win something or you do not win something. So now we figured out the probability of not exactly. We're just going to take and algebra that over to the other side. Great job. 100 points, Leo. We're going to algebra this over to the other side. And here we are right here. And it's going to be that the other probability is equal to 1 minus this. And here's the probability over here we're looking for. And then we'll look at our mathematics and see if it makes sense that we should see that those two numbers add to 1. So the probability of winning something is everything but not losing on each one. These are the tougher problems. These are tougher. And I think it says 3 decimals, but I want to point out, if you practice these problems and understand how to read them, it says to 3 decimals. Let's check answer. We have this right here. So these problems are tougher. But if you know what the question is asking, you can then decode a question. So watch this, Leo. This question right here is very similar. It says we buy a 5-pack of light bulbs, and we want to know the probability that at least one is defective. Well, either all my light bulbs are good or at least one is defective. So the probability of all my light bulbs being good is 0.832345. That's the probability they're all good. I don't want them to all be good, though. I want to find the probability at least one is defective. And so now this is the probability. And that should be it. And we just solved that question. But the thing is I understand exactly what the question is asking. It's saying, what's the probability at least one of my light bulbs is defective? So either all my light bulbs are good or at least one is defective. So I found out the probability that all my light bulbs were good and then subtracted that from 1 to find out at least one is defective. So if we do that, so what would that be? Leo, what does that stand for? Good questions, Leo, 100 points. 0.17 would be the probability of what? So 0.175 raised to the 5th would be the probability of what? That is the probability of a what? So 0.17 is the probability of a light bulb being what? And what would 0.175 to the 5th power then be? So this right here, 0.17, is the probability that a light bulb is what? Defective. So if I multiply this 5 times, the first, the second, the third, the fourth, the fifth is the probability of what? We just found the probability of what? So I just did 0.17 times 0.17 times 0.17. This is the probability. This could be described as what? Like, this is the probability of what? I just calculate the probability of what? So this would be the probability here of what? 0.17 times 0.17 times 0.17 times 0.17 times 0.17 is the probability. This is the probability that every single light bulb is defective. Does that make sense, Leo? Because we did the first is defective, and the second is defective, and the third is defective, and the fourth is defective. I think it might help sometimes to see it visually, really. See it visually, where we say the first is defective, and the second is defective, and the third is defective, and the fourth is defective, and the fifth is defective. So the first was defective, the first, the second, the third, the fourth, and the fifth are all defective. So if I did 1 minus this would be 1 minus all defective. So 1 minus all defective is going to be what? How would you then describe either all my light bulbs are defective or what? So I could solve this. What would the other side of the equation be worded? Either all my light bulbs are defective or what? Every light bulb will be defective in this 5-pack or what? So either all my light bulbs are defective in this 5-pack or what? So either every single light bulb I have is defective in this pack or what? So there's only 2 scenarios that could possibly occur. Either all of them are defective, or you could just use the complement word, the 3-letter word. So either every single light bulb in that pack is defective. Not a singular, though. Not a singular. Close, close, close. You're really close, Leo. Not like, you're close. Either every single light bulb in this pack is defective. Here, I'll show you. We got a 5-pack of light bulbs right here. 1, 2, 3, 4. 5-pack of light bulbs. Either every single light bulb is defective in this 5-pack. Either it is the case that either every one of these light bulbs is just defective in the pack, every single one of them is defective, or what? You're on the right track, and I think you know it. Just yeah, so it's either the case that every single light bulb is defective in that pack, or what? It's either the case that every single light bulb is defective, or what? Because the complement of them all being defective, it would be what? Because it's either the case that every single light bulb I buy is defective in that pack, or what? So it's either, I think you're gonna, you got it, Leo. You got it. Probably having a light bulb moment right now. It's either the case that every single light bulb in that pack is defective, or... So we could say all defective, or... Well, that's kind of the opposite. That would kind of be the opposite. It is either the case that every light bulb is defective, or... No, it's not letting me do it. It is either the case that every one of them is defective, or... Either every single light bulb in that pack will be defective, or... Keep going, keep going, keep going. It's either every single light bulb in that pack is defective, or what? Or what? You're close. You're right with the at least one. So either all the light bulbs are going to be bad, or what? At least one what? You got it, you got it, you got it. 100 points again. You got this. Right, you? Oh, that's fine. I'm throwing you 500 points for saying no, Coolio. That's fine to say. I appreciate that. We're just here to practice 500 points for saying no, cool. We'd like that here. At least one is not defective. So either every single light bulb is defective, or at least one is not defective. So think about that. There's many scenarios that could occur where you could have like one good light bulb. You could have maybe 3 good light bulbs. So either all your light bulbs are going to be defective in that pack you buy, or at least one is not defective. So either all the light bulbs you buy are bad, or at least one of them is good. Does that make sense, Leo? Like, there is the opposite. Like, they could all be bad, they could all be good, but either all your light bulbs are bad, or at least one is good. Does that make sense? So this right here, if we find out the probability they're all defective, then this probability right here, we could simply subtract from 1, and we could find out the probability at least one not defective. These take some practice. We'll do a lot of practice on these. These are some of the hardest problems, the at least one problems on the test. But when you get them down, you can usually solve them really quickly. Yeah, we'll probably do one of these at the end of class. But great work there, Leo. Excellent stuff. I might order those wires. So, Leo, we're going to head off a tiny bit early. It is tough. Good practice, Leo. Thank you for being here, Leo. Here, we'll head back to the main screen. I'm going to send out that announcement for class. So get ready. Good times to practice. Until then, I'll see everyone in just a little bit. 25 minutes till now. Bye, buddy. See you in 25 minutes.